Hello, everyone, and welcome to today's webinar. Today's topic that we'll be covering is integrating disparate data. My name is Greg Schmidt, and I'll be the moderator for today's webinar. And the main presenter for today's webinar will be Alan Jordan. Alan is our Senior Software Development Manager here at Fortra and our resident expert in the SQL Data Warehouse and SQL Business Intelligence. Today, he'll be covering SQL Data Warehouse and how it can help you solve your biggest data challenges. There's going to be a lot of great content in today's presentation. So if we do run over our 45-minute planned window today and you have to drop off, you will also receive a link after the webinar is finished for a recording that you can rewatch or send to someone that might not have been able to attend today's presentation. Also, feel free to enter your questions into the chat window and we can address them towards the end of the webinar if time allows. Okay, AJ, I'm going to hand it over to you to kick us off.
Okay, thanks very much, Greg, and welcome everybody to our webinar today. So this is our agenda. First of all, we're going to take a look at some common data challenges that many organizations face. Then we'll do a quick overview of the SQL Data Warehouse software to understand its features and capabilities. We'll take a deeper dive in how the software can make it very easy to integrate and merge disparate data. And we'll use two case studies for real customers to demonstrate how successful they have been with using SQL Data Warehouse in their data integration challenges. And we'll finally follow that up with a short demonstration, and we should have time for a Q&A at the end. It's no secret that operational databases are typically very challenging to work with and understand. Why is that? First and foremost, we need to understand that operational databases were designed to enable the software to process transactions, or in other words, to run your business. The databases must do that in an efficient, reliable manner and support all the steps that a transaction goes through. Think of an invoice transaction. It could be manually entered from a keyboard, or more likely these days it might originate by some sort of API. It needs to be priced, inventory may need to be checked and assigned, and then maybe it will be picked and packed and shipped. There's likely a lot of other ancillary steps that also need to be performed. The database structure was designed to support all those complex requirements. It wasn't designed for humans to access or for any sort of analytics. And best design practices result in many related tables. You often need to deal with cryptic data values, and in most cases, it's quite challenging to fully understand the data usages and relationships. And of course, there's really rarely any documentation. Software vendors just don't want you poking around in their tables. So this is the biggest challenge with integrating data and just understanding the data that you need to deal with on a day-to-day basis. But of course, we don't just have one database to deal with. Data's everywhere. 20 or 30 years ago, we might have had just one or two applications running on our IBM I or AS400s in those days, I guess. Today, we'll likely have dozens. Each database has got its own unique set of issues, and to make any use of the data that's stored, you or someone in your organization needs to be an expert in each of them. And often the data in these different applications is very much related. For example, the same customers and products likely exist in several different applications, but quite likely will have different identifiers and attributes. At the very least, they'll use different column names and table structures. And while your primary applications may run on the IBM I platform, it's almost a given that you'll have applications running on many different platforms. And of course, that's the main focus of our webinar today. Each of those will potentially need a different access mechanism with different credentials required. We've already talked about the challenges of related data in different applications, and that challenge is even more pronounced when they're in different databases running on different platforms. One often ignored challenge is poor data quality. In past webinars that we've produced, we've provided some frightening examples of the risks of ignoring data quality. But today I've just got one slide to talk about the financial cost. An IBM study from 2016 estimated that poor data quality costs US businesses in total over $3.1 trillion per year. That's a frightening number in my book. 2017 Gartner study estimated an annual cost to each business of around $15 million. These are really horrifying numbers. Think of the additional profitability or productivity that we could have if we solved our data quality challenges. And also note that those are several years old, so today's real costs are likely much higher. We can't address data quality across the entire enterprise in the scope of our topics today, but what we can do is to make sure that when we are bringing data together into a data warehouse, we don't load bad data. So we'll be talking a little bit more about that later on. So let's jump into an overview of the SQL Data Warehouse software. We'll set the stage by looking at those common data challenges. And your individual experience will vary with those challenges, but I'm sure that many of them were familiar to you, and maybe those are the reasons that you're here today. So after the quick overview, we'll focus on how the software can be used in integrating emerging disparate data. SQL Data Warehouse is a data management tool to build, define, and maintain data warehouse software. Data warehouses, I should say. It makes it very easy for you to build the tables and the indexes and other database structures that comprise the warehouse. And most significantly, you don't need to be a DBA or have the skills to create database objects. The software does it all for you. It's also an extract, transform, and load, or ETL tool, and this is probably the most crucial piece of the data warehouse architecture. It's the process that accesses the data in your source systems, transforms it, and loads it into the data warehouse tables. And that may sound simple, but in many cases, a complex task. So we will take a closer look at ETL in the next few slides. One major feature of the software is that it's driven by a metadata repository. Metadata can be thought of as the documentation layer that describes the data warehouse environment. And this includes technical information about the structure of the tables, etc., the ETL processes, but just as importantly, it can also include business level information. Every definition allows you to enter unlimited descriptive metadata to describe its purpose and usage. And that's very important. People may come and go in your data warehouse team, but this descriptive metadata can prevent critical knowledge and information from being lost over time. And this is one big factor in the long-term success of many of our customers' data warehouse implementations. And with SQL Data Warehouse, you're building a software application. It will grow and change over time, and as such, you need change management capabilities. And this is all built into the software with a very comprehensive and easy-to-use set of control functions. Activities can be tied to projects, definitions must be checked out to be modified, changes are automatically captured in the version history, and so on. And finally, it's a native IBM i application. SQL Data Warehouse is fully integrated with the IBM i operating system and the DB2 database. You can install any number of environments on the same IBM i server. For example, you'll have a development environment, maybe a test environment, and of course you'll have a production environment. And you might even have more than one of each. As an example, we have a large customer in Europe that maintains a separate data warehouse environment for each European country in which they operate. While the core design of each environment is very similar, they need to cater for the local requirements of each country and also consider privacy protection laws, etc. And many of our customers are financial institutions, and as such, security is very important to them. We've developed a very strong security posture which with the ability to secure each environment differently. That includes control over who can access the software, what they're allowed to do within the software, as well as managing ownership and security of the data warehouse tables that are created. We can access data on virtually any platform, and then we'll explore that in more detail in the next section where we talk about the data integration piece. And finally, we can also push data out from the data warehouse to those same remote platforms from which we can source data. And that completes the gives us a bi-directional data integration capability that many of our customers take advantage of. So let's now take a closer look at the ETL process. Some of you might be familiar with the concepts involved here, but it's arguably, I would say, it's probably the most challenging area of building a data warehouse. So it's worth a closer look. So extract. What does this involve? My slides are jumping around here a little. Let me go back a step there. Okay. So in the extract step, we specify how to access the data sources. And this is obviously going to be dependent on the source type, so it's not a one-size-fits-all approach. We also need to define the joins between the source tables and maybe select the rows that we want to load. In the transform step, some pieces of data just might move smoothly through the process unchanged, but very often we need to clean it up or derive new values as part of the step. You might need to use complex business rules using conditional logic. We have an extensive library of built-in functions catering for all types of data manipulations and transformations, and you can even create your own user-defined functions as part of this. And this is really where SQL Data Warehouse excels, with very, very powerful capabilities that allow you to manipulate the data as needed. The final step is to output the data to the target tables. The ETL process will automatically determine whether a matching row already exists in the target table. If not, it'll obviously insert a new row. When a matching row does exist, it will be updated. In this case, you can also use rules to determine how and when to update each column. For example, numeric values in an existing row may either need to be replaced or aggregated. We also need to validate the data. So about data quality earlier, it is a given that your data is not perfect, and I guarantee you will encounter issues such as failed joins, missing or invalid values, and other types of errors that would result in bad data being loaded. There's many types of errors are detected automatically by the ETL process, but you can also define your own business rules to identify others. For example, if a value must be present, it cannot be blank, you can build a business rule to specify that. Or maybe it needs to be within a certain range. And of course, if we're identifying and rejecting bad data, we also need to be able to set it aside and report on it, as well as providing some sort of mechanism to correct it and reprocess it. This is a unique capability of SQL Data Warehouse that is absent in most other tools. And finally, we have an automated subsystem to audit the important metrics of the ETL process. Things like when did it run, how many rows were selected and inserted or updated into the target tables, how many errors occurred, and much more. This is all collected automatically. An audit report is generated, and the details are stored in the metadata repository. And that provides a complete history of all previous ETL runs. And if you've ever gone through a data audit, you know how valuable this sort of thing can be. Depending on your industry, this auditing may even be a requirement that's mandated by law. So let's now start to look at the different types of remote data that is supported by SQL Data Warehouse. Most of the common commercially available databases are supported, but probably most commonly you will deal with remote, some sort of IBM data. It might be local data on the same LPAR, or more often than not, the data warehouse is built on a separate LPAR to production, so you'll be dealing with remote IBM data in a DB2 format. You have three different mechanisms that you can use to access that remote data. The first one, and probably the most common choice, is to use DDM files, distributed data management files. They're a very easy to use feature of the operating system, and the software will create them automatically as needed. So it's a very simple and easy to use approach. Alternatively, you can also access remote data by remote SQL. This is just as easy to define and doesn't require the creation of a DDM file. In some instances, it also might make sense to use remote journaling and change data capture to bring the data locally in the form of journal images. And this mechanism can be used to load the data warehouse in real time if necessary, if that's a critical requirement. So what about other database types? So we all know that each database vendor uses different technology to implement their database, and they run on different operating systems. Each of them has its own considerations. For example, the network location, security aspects such as TLS, certificates and credentials, etc. And also some vendors have implemented their own unique data types. An example of that is Microsoft SQL Server, which has a money data type, and that has no direct equivalent in DB2 where we're building our data warehouse. One commonality across virtually all commercial databases is the support for JDBC connections, and that allows us to make an industry standard SQL request for the data. So that's our approach for accessing most remote data sources. You might actually notice on this slide that Microsoft Excel is included in this group. So while it's not actually a database, we provide a JDBC connector that can load data from an Excel worksheet in the same way that we do from other databases. Now we could implement these JDBC requests directly in the ETL process, but our experience has taught us that the best approach is to stage this remote data before we use it in the ETL process. As such, when we're defining a remote data source, the software will automatically create a local DB2 table, and we pull the data into that table. Now the ETL process only needs to deal with local DB2 data. So it's greatly simplified, and it's much easier to join data sources from multiple different data applications. For example, you might have your ETL process might need to use 3 tables, A, B, and C. It doesn't matter whether table A comes from an SQL Server database, table B contains MySQL data, and table C was from Salesforce data in the cloud. The ETL is significantly simpler and much more robust because it's only dealing with the DB2 data. You might also need to deal with data from text files. In this case, you don't have the luxury of a database to give you any information regarding the content of structure of the data in the file. So we have a step-by-step wizard that's used to inspect and analyze the data in the text file. And for delimited files, that's pretty much automatic because it can use the delimiters to identify the data items and detect their data types, and then generating metadata that describes the structure of the data in the file. For non-delimited files, it's a little bit more complex. You need to place markers to identify where one column finishes and the next one starts, but it's still quite a straightforward process, manually identifying the columns and again generating the metadata that describes the content of the file. At runtime, the metadata then drives accessing data from the text file. For all intents and purposes, the ETL process sees the text file as a database file. So if we look at the overall potential architecture that we have, on the left-hand side, we've got our data sources, which might be IBM iData, either by DDM or remote SQL or through journal images. All of the other database or cloud data sources that are accessed by JDBC, and text files and Excel files, which might be on our IFS or on network shares. Notice that a lot of this data is brought first into the staging area and then processed through the ETL into the data warehouse. We also have the capability of exporting or pushing that data from the data warehouse out back to many of those same sources. Let's look at some case studies to give examples of how our customers are using the software. The first one is a financial institution in Europe. They're actually in Paris, France. They provide mortgages and personal loans, and they're handled by two separate IBM applications. And one of their challenges was to understand the entire relationship they have with their customers. A married couple might have a mortgage, and one or the other of them might have a personal loan, either individually or together, and that personal loan might be in force now, or it might have been in the past. And to complicate things even further, a person could have a joint loan with someone other than their spouse. And prior to this initiative, they had no visibility into any of these dynamics. So as part of their drive to understand their customers better, they implemented Salesforce as a CRM application. And then they chose SQL Data Warehouse to solve the data integration challenge that they now faced. So they got a hybrid scenario where mortgages and personal loans could now be created through the original IBM applications, or they might also be created through the Salesforce application in the cloud. So we've got customers being generated in multiple different places, and there's a need to synchronize information regarding these customers across the entire environment, let's call it. So SQL Data Warehouse is used to enhance and exchange the data between the applications, and there's bi-directional movement of data between the data warehouse and Salesforce. And as part of that is a customer matching process where there's quite a complex ETL setup that can identify if a customer that was created in Salesforce is the same customer that already exists either in the personal loan environment or in the mortgages environment. So SQL Data Warehouse is providing a very significant value to the business in performing all of these tasks. And of course, they've got their traditional data warehouse workload for analytics and operational reporting too. The second case study is a long-time customer of ours. It's an insurance company called Life of the South, and they've given us very generously given us permission to talk about them in this webinar today. They first implemented the software in 1998, and in those days the software was called Rodan, and it was acquired by Help Systems, now Fortra, 9 years ago, and renamed to SQL Data Warehouse. They were a family-owned company operating in a single location in Jacksonville, Florida. And in 2004, we did our first case study with them. In fact, it was IBM that sponsored the case study. There's a image of the front page of it here on the chart. And one of the things that they highlighted at the time is that they were after implementing the software a few years later, that identified that we're saving approximately $1 million per year that was credited to the implementation of the data warehouse. I was involved at the time. I don't recall exactly what the metrics were that were made up that $1 million saving, but it was certainly a very good success story for us at the time. Fast forwarding a few years, they changed their name to Fortegra in 2009 and had grown significantly. And we did a second case study in 2017. And this case study is actually available on our Fortra.com website. They continue their rapid growth into new business areas, expanding globally, and they now have 15 locations worldwide. So as part of this growth, they've got implemented new applications. So they've got several IBM applications. They've got multiple Microsoft SQL databases. I think they also have MySQL. And more in the last few years, they implemented their Oracle General Ledger and accounts payable in the cloud. So as you can imagine, they've got data in many, many different places. All of that data moves through the data warehouse as part of their integration process. So and they've identified the data warehouse as one of their most important and critical applications, and they've even marketed it as a differentiator when forging new partnerships. One of their business expansion areas is to be a service provider for other insurance companies, managing the premium payments and claim process. And they use the data warehouse as their one of their marketing tools to show how well they can perform this service for other companies. There's a lot of bullet points on this slide regarding some of the different things that they're doing. I'm not going to go through them all, except I do want to point out one of the last ones here is that they're now embarking on AI, artificial intelligence journey, and they're using the data warehouse to build the data for their learning models. And believe it or not, all of this was built and managed by a team of 2 people over the years. They are now starting to expand the team because of the AI applications that they're building, but it's certainly a significant achievement to build such an important and critical application by just 2 people. And they have been now, this year in 2023, they've been a customer of ours for 25 years. I've been privileged to be we have been privileged to be a contributor to their success and growth over the years. But also, in turn, they've helped us to evolve the software. So the enhancements that they've requested and that we've delivered to them over the years have certainly benefited our entire customer base. So next, I want to now perform a brief demonstration. We're not going to go into every aspect and capability of the software. I'm going to focus on the data integration for disparate data types. Just bear with me a second. Okay. So we're looking at the client, which is the designer piece for the data warehouse. I've got 2 different instances, 2 different environments that I have installed. I'm going to work in this demo environment here. And to start with, we'll look at the data acquisition or managing the data sources. So different types of data are organized by source group. Oops, there we go. It's decided that it's logged me out, so I'm going to log back in again. There you go. I think it was idle too long is the problem. These sort of things always happen when you're doing a demonstration. Okay. There we go. Yeah, there it is. It was the original one was complaining about that. So I've got multiple different source groups here. So each of them may be a different remote data type. So I've got a Microsoft SQL application, which is the AdventureWorks demonstration database. I've got some local DB2 tables, some DB2 DDM tables that are pointing to remote DB2 on different LPARs, an Excel group, and also a text files group. Let's look at the Microsoft data sources. So our metadata captured all the information regarding the remote table. And if you recall, we build a staging table here. So we have a local DB2 table, which is representation of this customer's database. And I want to show how easy it is to actually perform that step. So I'm going to I want to create a new one. Okay, so I'm going to add a new Microsoft table from the AdventureWorks database. And I know the schema is called sales LT, and the remote table that I want to use is this sales order detail table. So I'm going to look at Microsoft SQL Server Management Studio, so I want to introduce this as sales order detail table. Okay, and it will default with the same name, and I'm going to call it sales detail as my local table. That's now making a connection using the connection information that was previously stored, retrieving the metadata, and showing me the columns that exist in that table. So here we can see here we've got a Microsoft Money data type, but we're going to implement that as a decimal data type in our local copy. I can choose whether I want to select all of the columns. I might say, no, I don't want this row unique identifier. That means nothing to me, so I'm going to exclude that from my table. Hit next. And now I can type in some metadata to describe what the purpose of this table, the usage is, and then finish. So at this point, it is now creating a local DB2 table, which is a copy of that Microsoft table. And that's now completed. I can sample it and find that it is empty. I have no data. So let me close that. And let's perform a load. So I can either add or replace. I can use runtime variables to make my selection. I'm not using any right now, and I just click OK. It might take a few minutes to do the load, so it has submitted that to batch. But I think this one doesn't have a lot of data, so it should already be loaded. And there is the data we now have. So we've now got DB2 representation of that Microsoft data that I can join easily to a text file. I can join it to any other type of data that I need to. Let's look at an ETL process. I'm going to go down to this one here. This is an invoice load, so it's loading transactional information. So on the left-hand side, I've got my sources of data, and this particular ETL loads into multiple target tables. So we can take from multiple source tables and load into multiple targets. You can visualize the ETL, what's happening inside that ETL process. I can see the table joins. This is a user exit program here. I've got some derived values, and I can see the order in which we're going to do some processing and points at which we can reject the data. And on the second tab, I can see the movement of the data. This one, it looks quite busy, but I can focus in on individual source to target relationships. This gives me this visual representation, makes it very easy for me to understand how the data is moving and what rules might be in place. For example, I can drill into this table, and it has a rule here, which is a reject rule, reject if the cost is 0. Let's close that. No, I don't want to save my changes, and I'm going to run it. Normally you'd schedule this, but when you're in development test mode, you would run the things manually. I've got a runtime parameter where I can make a date selection. I'm not going to do that right now. I'm just going to select or process all of my data, and it is submitted it. So I click on the show job. Taking a little time to build the screen here. I think this is my... Anyway, I know the job is already finished because I've already got an email notification telling me it has finished. So we can close that. We had some errors. So this indicator here is telling me that 424 errors happened in the load process. So let's look at the email that I just received. Here it is. And it's telling me that 424 of 16,000 rows were rejected. I can look at the audit report, which it sent to me. Lots of information that was captured, the start time, finish time, number of rows that were loaded or inserted and updated into each table, and also the error report gives me the details of the errors that occurred. Yep, all 424 errors were for the same reason. The rule that we just looked at, the cost was 0. So 424 rows had a 0 cost. They got rejected. And finally, we also have the capability of pushing data out to other remote targets. So I've got one here, I believe. I think it's this brand sales summary. Nope, not that one. Maybe it's this one. I was prepared better. One of these. Must be this one. 6th time lucky. There we go. So as we load data into this data warehouse table, it could also be pushing data out directly into this remote SQL server table here. So this gives us our bidirectional capability. So we can push the data at a point in time, or it could be pushed automatically as part of the ETL process. So it could be a real-time output to some remote target, in this case an SQL server table, at the same time as we are loading the data warehouse table. So this is a brief overview. There's a lot more to talk about regarding the capabilities of the software beyond the scope of first of all, our time limits today and our focus on integrating data from multiple places. So Greg, I'm going to turn it back over to you.
Yeah, thanks, AJ. Yeah, thanks for the great demonstration and information. I always have to stop because I always have to unload my brain a little bit after you're done, because I always get so much more information on SQL Data Warehouse. So it's I always learn something new every time. So
Yeah,
all
great.
right. Yeah, so what I'm going to do here now is I'm going to look at some of the questions that were coming in. We'll take a few minutes for some questions, and we'll see what we have here. And there's a good number of questions out there, but for time purposes, I'm just going to pick a few of them to answer. And then if we don't get to your question here today and get an answer to it, we will contact you after the webinar and get you an answer. All right, so let's take the first question here. Some of these might have came in before you actually covered this, but it doesn't hurt to recap a little bit. So what data sources can be connected to with SQL Data Warehouse?
Okay. Most commercial databases, so we're talking about Microsoft, SQL Server, Oracle, MySQL, Postgres. We also have connectors for Salesforce in the cloud. And in fact, we have a partner who has connectors available for many, many different data sources. So some of these are in application level connectors. Some of them are also more obscure databases like Sybase. So I don't have a definitive list, but I connect but the ones that we commonly encounter are probably those Oracle, Microsoft, DB2, of course, DB2 on other platforms. Salesforce is quite common, but we also have the available connectors for many other data sources. And I can't say we've worked with all of them, but they are definitely available.
All right, perfect. All right, next question here. Yeah, this is a good one, just to sort of recap as well. Where can I run SQL Data Warehouse?
It is a native application from an IBMI perspective, so it installs only on an IBMI. But as you know, most of the customers in the audience today, I would guess, are IBMI centric, or at least have a good IBMI presence. And why not run it on your IBMI? It's a cost-effective server. It's rock solid, secure, and in fact, I just saw just last week, I think an IT Jungle article talking about how an IBM survey that suggests it's very, very cost effective.
Good. All right, perfect. All right, and then the next question here, let's check on time. Yep, next question. How technical does someone need to be to do this? Do they need to be a programmer?
You don't need to be a programmer. That's one of the features of the software is it takes away the need for programming skills. However, does it help to have a programmer or at least somebody with a good database understanding on the team? Absolutely. But I would say far more importantly, you need people with a skill, with the knowledge of the source applications and your business. What is it you're trying to do? Where does the data reside? And what are the idiosyncrasies regarding that data? So those are far more important skills, let's say, than being a software developer or a programmer.
Okay.
But does it hurt? No.
Awesome. Perfect. All right. And the next question here, and I think you touched briefly on this in a couple of the last slides, or one of the last slides that you're going through there, but our business moves at a faster pace and business users need real-time information. Can we make real-time updates to SQL data warehouse?
Absolutely, you can. And that's one of the things that as I was designing this webinar, designing the presentation, I was recognizing that we weren't really covering that in any great detail. However, uh, if we think about a data warehouse, data movement, in a lot of cases, you don't need it until tomorrow or next week if you're building a data warehouse because you're looking at things that happened in the past. But equally, you might be doing operational reporting where you want to see something that happened earlier today or happened a few minutes ago. We support that from IBM iData coming into from IBM iData because we can pick up from the journals when the data is generated. We do not support it directly coming in from IBM from Microsoft or Oracle data sources. However, we do have customers that are using change data capture from the journal images to bring in data in real time into the data warehouse from IBM iData, and then pushing real time back out to other platforms such as a Microsoft database. And one example that comes to mind is transactions are being generated through their ERP applications, and then there's pushed out in real time to a Microsoft database, which is then providing, I think it's product inventory information for their web applications, which is driven by Microsoft. So yes, we have real-time integration. Does it always make sense? Is it always possible? It depends.
Perfect. Okay. And the next question I'll take here, it's an easier one for me. We have a couple people asking if they can get a more detailed demonstration of the SQL data warehouse. For the ones that have put that out there, there's a couple of them out there that I see here. We will contact you individually and get them scheduled at your convenience.
Yep.
And I just want to thank everyone for attending today's webinar, and thank you, AJ, for going over and doing the presentation and giving all the knowledge that you that you gave to us here today. If anyone has any other additional questions, feel free to reach out to our SQL Business Intelligence sales team here at Fortra. And we would also be happy to schedule that free, consultation or live one-on-one demonstration to address any of those different kinds of business use cases that you might have. And again, like I said in the beginning of the webinar, you will receive a link to the recording or to a recording to the webinar here, and that you can share with anyone in your organization that could not attend today's session, or if you'd like to rewatch anything at any time. Thanks again for attending today's webinar. And again, thank you, AJ, for the wonderful presentation and sharing your knowledge.
Thank you, Greg, and thank you
yeah.
for everybody that took the time to attend today.
Yeah, thanks, everyone.